All right, so number 5 is doing completing the square. If you want to solve this a different way and just check the answers, that's fine. Ms. Yonda and I didn't cover completing the square in class. We use that as a different option. I'll show you how to complete the square now if you'd like to learn. So it says x squared minus 14x minus 15 equals 0. A couple of things about completing the square is we need 1 as the coefficient of x squared. We need an a that's equal to positive 1. And then we need all of our constants on the other side. We have 1 as our coefficient, but we are going to add 15 to both sides. So this one's a little bit different. X squared minus 14x, you're going to leave some space because we're about to input some information in here, and that's going to equal 15. Now, what information do we need to put in? It's called completing the square because we're going to turn this equation into a perfect square. All right. How do we do that? Is we take this b value right here, and we divide it by 2, which would give me negative 7. And then we're going to take that negative 7 and we're going to square it. And that gives me positive 49. So I'm going to add 49 to this side. But I'm also going to add 49 to this side to make it equal. Anything I do to one side, I have to do to the other. You remember that rule from way back? All right, so rewrite. X squared minus 14x plus 49 is equal to 15 plus 49, which is what, 64? All right, and do you see how that's a perfect square? And do you see how this is about to be a perfect square? If I were to factor this, I would say x, and then we have, it's going to be either both plus 7. It's a perfect square, meaning these have to be the same. It's either both going to be plus 7 if this is a plus sign, or minus 7 if this is a minus sign. So x minus 7 and x minus 7 is equal to 64. Now, another way I could write that is x minus 7 squared is equal to 64. Now I'm getting to business here. How do I get rid of a square? Is I do the square root. So I'm going to do the square root over both sides. And I'm going to get, what that square root does is it gets rid of that square sign. And this is a perfect square, so that gives me 2 values now. I'm going to have x minus 7 is equal to the positive and negative version of 64. So now we can create 2 equations. I have x minus 7 equals positive 64, and I have x minus 7 equals negative 64. Now I just add 7 to both sides, and I'm done. So I will get x equals, what is that, 71, and x equals negative 57. Let me double check that. Negative 64 plus 7. Woo, negative 57. So these are my 2 answers. I have x is equal to 71 and x is equal to negative 57 through completing the square. I hope there's no questions about that. Watch the video. I'm going to do the same thing for the next one as well, number 6. X squared plus 6x plus 25 equals 0. Can't have that 25 on this side, so I'm going to move it over here. I already have a 1 as the coefficient of x squared, so I'm going to rewrite x squared plus 6x, leave some space, equals negative 25. I'm going to divide this one by 2 and get 3, and then I'm going to square 3 and get plus 9. So I'm going to add 9 to both sides. Now I have x squared plus 6x plus 9 is equal to negative 25 plus 9, which gives me negative 16. All right. Now, I have x squared plus 6x plus 9 is equal to negative 16. I'm going to split this up into a perfect square, which says x plus 3 and x plus 3 is equal to negative 16. Okay? So, another way of writing this is x plus 3 squared is equal to negative 16. Now, I'm going to do the square root over both sides, and I'm going to get x plus 3 is equal to the square root of negative 16. Uh-oh, SpaghettiOs, right? Let's graph that one really quick, and let's see what we see. You remember, if the parabola doesn't touch the line, doesn't touch the x-axis, then that means that there are no solutions. So we have x squared plus 6x plus 25. I'm going to hit graph. Zoom, fit. Does it touch the line? I'm willing to bet it does not. Let's zoom in on that vertex real quick to see if it ever touches the line. Zoom in. It never touches the line. So that tells me that there is no solution. As soon as we have a negative inside the parenthesis and underneath the radical symbol, we now have no solution. Okay? If that were a positive symbol, we could say x plus 3 is equal to the positive negative version of 4, but we can't say that, and we can go ahead and solve that. But because there's a negative underneath the radical, we're talking about some number that is impossible to solve. So we stop right there with no solution. Number 7. Number 7 says, solve the following equations by using square roots. Square roots are the really, really easy things that we covered. We're just looking for perfect squares. We have 4x squared is equal to 25. And all we're doing here is, first of all, we check to see if they're divisible by 4 to make sure our x is 1. They're not, but we see that we have perfect squares as numbers. We see if we have an even power. So we can do the square root over each side. And we're going to get 2x is equal to positive and negative 5. And now I'm just going to set it up as 2x is equal to 5 and 2x is equal to negative 5. I'm going to divide by 2 on both sides of each equation and get x is equal to 5 halves or 2.5. And x is equal to negative 5 halves or negative 2.5. 8 is very similar. We have 16x squared minus 3 is equal to 141. I'm going to add 3 to both sides. And I'm going to get 16x squared is equal to 144. Is 144 divisible by 16? It is. So I'm going to go ahead and divide this side by 16 and this side by 16. And I'm going to get x squared is equal to 9. This is still a perfect square. We could have done it back there, but this is still a perfect square. Do the square root of each side, and I will get x is equal to positive negative 3. Or x is equal to positive 3 and x is equal to negative 3. Okay? Number 9, solve using the quadratic formula. You better believe you're about to see a video posted of the quadratic formula, or at least attached. So it says 2x squared minus 9x plus 8 is equal to 0. It's in the right form. It's in the right order. We can't GCF, so we move on. We know that this is our A, this is our B, and this is our C. So our A is equal to 2, our B is equal to negative 9, and our C is equal to 8. And we know that the quadratic formula says, sing along with me. I'm kidding. X equals negative B plus or minus the square root of B squared minus 4 times A times C all over, and that means the whole thing over 2A. Okay? There's a reason why I wrote these in parentheses, is because it's all multiplication. So let's input these values into the equation and solve. So x is equal to negative 9, which is positive 9, plus or minus the square root of negative 9 squared minus 4 times 2 times 8, all over 2 times 2. We always work this out first. So that says the square root of 81 minus 4 times 2 is 8. 8 times 8 is 64. 81 minus 64 is what that's going to say. 81 minus 64 is 17. Can I do that? No, it's still going to be ugly. So we have the square root of 17. Now, can I factor that out? Can I pull out any perfect squares from that? The answer is no again. I'm looking for numbers like 4, 9, 16, 25. Those factors that I can pull from this number. I can't pull any of those numbers. So I just keep it as the square root of 17. So here I have x is equal to 9 plus or minus the square root of 17 all over 2 times 2 is 4. That is my answer. If I could pull something out of this, pull a perfect square out of this, I would have some chance at reducing this. Remember, to reduce this number, the number outside of the radical symbol, and the denominator all have to be divisible by the same number for you to reduce. Okay, so this is my answer. I get 9 plus or minus the square root of 17 all over 4. Do you have time? Yeah. Let's go ahead and knock out the other one as well. Number 10. 6x squared minus 9x is equal to 15. Now, I know to do the quadratic formula, I need everything on one side. So minus 15 on both sides, and I get 6x squared minus 9x minus 15. Equals 0. Your spidey senses should be tingling. These are all divisible by 3. So I get 2x squared minus 3x minus 5 is equal to 0. This is my A, this is my B, and this is my C. So I do x equals negative b, which is positive 3, plus or minus the square root of negative 3 squared minus 4 times 2 times negative 5 all over 2 times 2. So we do this section, the radical section first. That's going to be the square root of negative 3 squared, which is 9, minus 4 times 2 is 8, and 8 times negative 5 is positive 40, so plus 40. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is positive 40. So now we have 9 plus 40, which is the square root of 49, which we know is 7. The positive and negative of that is taken care of right here. So now we have two different equations. We have x equals 3 plus 7 all over 4. And we have x equals 3 minus 7 all over 4. 3 plus 7 is going to give me 10 divided by 4. And I will get x equals, what is that, 2.5. And I will get, over here I have 3 minus 7, which is negative 4 over 4. So that will give me x equals negative 1. So these are my two answers here. I have x is equal to 2.5 and x is equal to negative 1. All right. How do we know those are the answers? If I wanted to, I could take each of these terms and plug it back in for the x value here and here. Plug that into my calculator, hit enter, and I should get 0. Same thing with the negative 1. Remember, when x is this and x is that, then y is equal to 0. Okay? I'm going to stop here and continue on the next video.